A common unit of concentration in chemistry is molarity. In fact, all of the reagents or chemicals that we've used in lab this semester have come to us with concentration labels using the unit molarity, or the capital M. So the equation for molarity is in the pink box. The abbreviation for molarity is capital M. Okay, so I want you to remember that the abbreviation for mole is MOL. So don't confuse mole with molarity. And so molarity is abbreviated, like its symbol would be a capital M, not anything with the letters of molarity. Okay, so just don't confuse that. Now, if you look, one of the things that is the same when comparing to percent concentrations is that we are comparing the solute to the solution. So in both percent concentrations, which are discussed in a different video, and this unit for concentration, we're comparing the amount of solute we have in our solution. Now, important things that are different. One is the units we're working with. So our solute on top will always be in moles. So there's not variation like there are in percent concentrations when you can compare mass or volumes. The top will always be in moles, and the volume on the bottom will always be in liters. And so that is a very important thing to remember when you're solving problems, is that molarity has to be in moles of solute to liters of solution. So remember that. Again, I won't give you the concentration equation. You can either learn it, or if you want to put it on your card, you can put it on your card. The other difference here, which you probably identified, is that since it's not a percent, it doesn't have a times 100. So for molarity, there's one equation, and it's the moles of solute over the liters of solution. Now, the little illustration here on the right-hand side is simply to give you an idea about how solutions are made, so that when you read problems, you might have a small visual of what goes on in the course of making the solution. So you would have to know the amount of solution you want and the amount of solute you want to put in. But in this case, they're adding, looks like 1 mole of solute. Usually it's in grams, but that's okay. So you're adding your solute. So you can see there, they're adding solute into, just so you know, this is called a volumetric flask. So in lab, to connect it to something that you know about, in lab we used a volumetric pipette. This was earlier in the semester, and it was where we used the bulb and drew up the liquid, and you had to get it to the little marking on the pipette. And volumetric glassware are really good for 1 volume. So they'll measure it to the hundredths place if you do it correctly, 1 volume. So here, like they see at point, there's the little line on the neck of this flask, and it looks like it's 1,000 milliliter flask. Okay, so you would put your solute in, then you add some water and try to dissolve the solute. Well, it says add solvent, I'm just thinking water, but you add your solvent to try to dissolve your solute, because when you dissolve the solid into the liquid, the volume might fluctuate a little bit. So you don't want to add it all right up. You want to get your solute dissolved, and then you can see they fill it up to the 1 liter mark. And so then we know this is our total solution. And over here we measured, before they poured it in, they measured our solute. So you're going to have a known amount of solute. You add it to the container, and then you add solvent carefully up to a known amount of solution. All right, so let's try. I have two problems in molarity, one solving for molarity and one solving for something different. So let's look at those. So it says, calculate the molarity of the solution prepared by dissolving 9.35 grams of potassium chloride in enough water to make 250 milliliters of solution. So there's that idea again. They're not telling us how much water, but all we need to know is how much solution there is. So for myself, when I know there's an equation to use, I do like to write it down. So it's going to be the moles of the solute over the liters of solution. Now, on occasion, they will give you moles and or liters, and then you would just plug it in. But it's very common for you not to have units of moles and liters initially, but to have grams and milliliters. So before we use our equation, we're going to have to convert grams to moles using the molar mass, which we'll get in a second. And then I'll leave space for that. And then we're also going to have to convert milliliters to liters. All right, so let's see. We need the molar using molar mass. I probably said it and didn't write it. Okay, so K and Cl. So we're going to have to get our periodic tables and look up the mass of these two elements. So I have one potassium, and it is, one time is 39.10 grams per mole. And then I have one chlorine is 35.45 grams. So since there's only one of each, I just add them. So that's 5, 9, 14, 74.55 grams per mole. Okay, so I'm moving things around on my table. All right, so now to convert, we take 9.35 grams. And to go from grams to moles, we're going to divide by the molar mass so that the grams cancel. So on my calculator, 9.35 divided by 74.55, I get 0.125 moles. And I just rounded it here to 3 significant figures because that's what I was given. You don't have to round at this intermediate step if you don't want to. And then milliliters to liters, I have 250 milliliters. I know that there's 1,000 milliliters in 1 liter. So I'm going to divide by 1,000. I get 0.2500 liters. So now I did all that work and I don't have my answer yet, but I am getting closer because my molarity is going to equal the moles, 0.125, over the liters. And so 0.125 divided by 2,500. And I'm going to tell you, I didn't do by 0.2500. Okay, let me do that again. I was going to tell you, 9.35, that I left my moles in my calculator, so it wasn't rounded. So just to tell you, so 0.2500. And I get 0.502. It's 1/6, and I'm going to 3, and then the capital M is how we write it. You could write moles. I guess you could write moles per liter, but usually they write a capital M. Now I'm curious. Okay, So if I didn't round, if I rounded at an intermediate step, then I would get 0.500. Now, for me, it's not a big deal, but it could be in your homework. So let me explain, because if you were with me, I could explain more easily. To arrive at this answer right here, I had not rounded my moles in my calculator, and I just took that number, not rounded, and divided by the 0.25, and I get the 0.502. If I round, which I really personally don't have any problem with, if I round to 0.125, then I get 0.500. I'm not sure that would be within the error range on the homework or not. On an exam, as long as I can see your work, it would not cause a problem at all. But on your homework, if you find that you think that's what's happened, reach out to me before you get yourself too frustrated. So anyway, that was just a small variation, not a big deal. Okay, so let's do one more. Then we'll be done with the calculation. This is the last thing for chapter 14. So it says, how many grams of KOH are required to prepare 600 milliliters of a 0.54 molar solution? Okay. So in this problem, in this case, I know the concentration. And let's see how many grams. This is the solution. And I need to find the solute. Okay, so I'm going to show this again two ways. Let's use our algebra. So I know that molarity, and I know I would use the molarity equation because it's capital M. So molarity equals moles of the solute over liters of the solution. Okay, so I need to convert milliliters into liters. So 600 milliliters. So 0.6. Okay, so let's plug in now. So I know the concentration is 0.450. If you like to think of the units, molarity, the capital M, this is moles over liters. Then I don't know my solute, and I'm just going to call it X. And then on the bottom, I have 0.6. So I'm going to multiply the 0.6 to the other side. The liters cancel. And that's going to give me X in moles. So 0.450 times 0.6. And I get 0.27. If I'm keeping sig figs, I need at least 3, and it's moles. Now, if the question just asks for moles, I would be okay, but it asks for grams. So now I have to convert moles to grams using molar mass. And what was it? K we just did. K is 39.10 plus we have 1 oxygen, which is 16, and 1 hydrogen, which is 1.01. It's easy when there's only one of each. 56.11 grams per mole. So then I take the number of moles, 270 moles, and to go from moles to grams, you multiply by the molar mass so that the moles cancel. So times 0.27. And I get 15.1497. So to 3 significant figures, 15.1 grams. This is of KOH. So we would have to measure out 15.1 grams of KOH. That would be how much solute we would need. And then we would add up water to make us 600 milliliters of solution. And that would give us our concentration. Now, I can do this also like a conversion. So let me show you. You still have some of the same issues, but let me show you. Again, like in the previous video, you don't have to do it this way, but I just want an alternative for those of you who think, oh yeah, I see that, and it's easier for me. Okay, so let me look back. It was 600 milliliters and 0.450. So the concentration is 0.450, capital M. And then the volume of the solution was 600 milliliters. Now, because it's milliliters, we would still have to convert this to liters. Like that, we can't get away from that because we have to have liters in molarity. So I would still have to do that. And then the other thing, so now molarity, capital M, tells us whatever the number is right here, that we have that many moles in 1 liter. That's what the concentration tells us for molarity. It tells us the number of moles we have in 1 liter. So if the number was 2, capital M, if it was 2 molarity, there would be 2 moles over 1 liter. If it was 0.125 molarity, it would be 0.125 moles over 1 liter. So whatever the concentration is in molarity, it tells you that you have that much in 1 liter. So just like any other conversion problem, don't start with we're going to use this is going to use as a conversion factor. So don't start the problem with conversion factors. Okay, you're going to start with the other stuff. So we know that we have 0.6 liters. And then we're going to use the concentration here. Since it's liters, we're going to put the 1 liter on the bottom and the 0.450 moles on the top. So we get the same thing that we had before, 0.6 times 0.450, and that gives us 0.270 moles. And then we would have to convert to grams, which I showed you on the previous page. And so I don't think I have to do it again, but we couldn't end up in moles, but you see we got the same answer. So again, you don't have to do it this way. I just want you to see an alternative. All right, so try to practice. That's how we get better. And if you have any questions, be sure to ask me in class or via email.